Hi, welcome to Data Appreciation with Shino. And today on Google Skills, we'll be exploring the Lakehouse. It's part of the Google Cloud Data Analytics Certificate. As a data analyst, you likely encounter three main data architectures: data lakes, data warehouse, and lake houses. A data lake is a database system that stores large amounts of raw data in its original format until it's needed. The guiding principle is to collect data first and decide what is useful later. This is our scenario. As a cloud analyst at Look e-commerce, a global clothing company that specializes in innovative fashion and ethical sustainable sourcing. Meredith, the head of merchandiser, has asked to help them complete a series of tasks to understand which products are selling, which products are being returned, and ensure that the cost of each product is up to date. To get the job done, you need to combine data from a data lake and a data warehouse. By doing that, you use BigQuery as a lake house. You use this hybrid architecture to find the data to address Meredith's business concerns. Here, how you do this task. First, you create an external table that points to data stored in the data lake. Then you join the external table with a standard BigQuery table and explore the combined data. Finally, you will import the data into a CSV file. From CSV file into a standard BigQuery table to better understand the difference between external and standard tables in BigQuery. Our first task is to use an external table, create and use an external table. Let us start our lab. We would open Google Cloud Console in incognito window. We would agree to the terms and continue. After some preliminary data analysis, Meredith is concerned that there are too many pairs of jeans being returned. To help her gain a better understanding of the situation and which distribution centers have the most returns, Meredith has asked us to create a report that details how many product returns have been made for jeans at each distribution center. So we'll go through our navigation menu, select BigQuery, and we'll click on SQL query addition icon. BigQuery. This is the SQL addition icon. So note in the following query We have a file type called the parquet. The parquet is a popular format for string data in cloud data analytics. Comes side by side at times with the delta format. So we'll copy this. And remember, since parquet files are compressed, they take up less storage space. They are also easy to manage since the data schema is stored within the file itself. And also, when you create an external table in BigQuery, we are creating a table that points to data stored in an external location, such as the cloud storage. The data types of the columns in the external table will be inferred from the data in the external location. So our query has created a new table named product returns. Let's go to our table. When you create an external table in BigQuery, you are creating a table that points to data stored in an external location. The data types of the columns in the external file will be inferred from the data in the external location. Where did the data types for each column in the product returns table come from? The data types were inferred from the public data set. The data types were inferred from the Apple file set. Data types were inferred from the Pago file set. The data types were inferred from the Save file set. So you can remember we talked about Parquet. Now check the table properties for the table just created. In the Classic Explorer pane, expand the list of data sites by clicking the drop down next to the project ID. Drop down next to the project ID. So we click the drop down arrow next to the look GCDA dataset. This is the drop down. Select the product returns table. Refresh your page if it's not listed there yet. So this is our product returns table. Refresh the details tab and sort the details in the external data configuration. So we're going to the details tab, and this is our external data configuration. Check the source URI column and notice the pointer GS. In the BigQuery UI, the source URI column shows the location of the data source for a table. The GS prefix in the source URI column indicates that the data is stored in the cloud storage. When you create an external table, the table is stored at the source location in the cloud storage, but can be queried just like a standard BigQuery table. How do you know that the product returns table is an external table? By external data configuration information, which is what we have here, the external data configuration. That's how we know. Now we'll copy the following query into the query editor. Note that each time you run a new query in the query editor, you can either replace the old query by copying and pasting the new query over the previous one in the same untitled tab, or you can click the positive icon to open a new untitled query. So we can come here to pick a new query, or we delete what we have here. Let's go to a new query, copy this. Note what is going to be our results. The query has confirmed that we process it. We will run it. You can see row count 20,000. So select count as row count from the look GCDA product returns dataset. Next, we'll check the properties for the distribution centers table. In the Classic Explorer pane, you look GCDA, select the distribution center. We'll go to distribution centers table. These are our distribution centers. Select it. We have the details. We will study details in the table info and storage info sections. This is not an external table as no external files are referenced. So we have a table ID, time created, last modified, table expiration, data location, storage info, number of rows, total logical bytes. Okay. So question here is when data is imported into BigQuery as the BigQuery standard table, where is the data physically stored? An external data source? No. BigQuery is the vector file system, a point in time copy file called a snapshot, a materialized view. So remember from what we have here, This cannot be our answer. Not this, not this. So let's test this first. So it's BigQuery distributed file system. Now we'll check the product returns table data we created in the previous step. Copy the following query into the query editor. So select all from the look CD product returns. We'll order it by status date in the descending order and limit is 10 results. So let's see the results. Okay, 10 results as expected. Order descending. By status date. So this is our status date and it's descending. In 23, June 12, June 11. The query must turn result based on their return status date. Now copy the following query into the query. So let's see another query. Select DC name and PR from the look as PR, that is our alias, and now join the look as DC on DC ID is equals to PR distribution center. So we can see this message is coming up because we're already using cloud credits. So this query joins data from a cloud storage bucket product returns with data stored in BigQuery external table in different centers and returns the different center name along with all the columns from the returns data in the package file. Now we should copy the following query to query editor. Let us see this. This query generates information Mary is requested. The query displays the distribution center's name, admission center's name, and the number of products in each category is being returned. This is it. Return column. These are return counts. These are category. These are the different centers. So we can centers and the counts. See the highest is New Orleans with 161. So our second task is import data through the console from BigQuery Studio. The list of product names and updated product costs were sent from a key manufacturers. Merity needs to have this data updated to reflect new costs and make sure they have the most up-to-date information in their reports. The manufacturer sent the list in CSV format and tech support has copied it to a cloud storage bucket. Tech support also sent a screenshot of the file so we have an idea of what should be displayed. Now, note that the first line has the names of the columns. The file has two columns and what separates the columns is a comma. So the first line, the names of the columns. Okay. The product name and new price. This file is located in the Google Cloud Storage bucket called Short Skills Lab Dev in the price update folder. In this task, we'll import the data into the loop data set. So we switch to Explorer pane and click on Add Data to add a data source to the project. So go to Explorer pane, click on Add Data. Project. Should be able to add data to this. So here under the Explorer pane, we'll click on Add Data. We'll select Google Cloud Storage and select External or Big Lake Tables. Let us save our queries. So what Google does, it makes sure we don't leave without saving because we change the views and we lose our queries. So I think there's something. Our query is being requested to be saved, so it has been saved. So let's just add all that in. So remember, we're going to the Google Cloud storage and external or big lake tables. So here's our Google Cloud storage. We have external or big lake table. So we have to put in our options. We'll select file from GCS bucket and we'll type in this to get this particular file. Next file format, we select CSV. Next, we would destination for data set, we'll select the look CDA. Okay, data set project stage, the look GCTA, the table type, table field will enter the shared price update. Table type, set it to native table. Schema will check auto detect. BigQuery will try to get the data types by checking the values for each item, and we'll click on create table. So our table has been created. How many columns were imported? So how many rows are on the table? So we'll go and see the table and look at any properties we have on the table. Excuse me. Remember, our table name is called shared price update. We have two fields. We have 50 rows and 3 columns. Okay. Beside our index, we have 2 columns. How many rows are in the table? How many rows in the table? Okay, we have 1 to 50 of 200. So we have 200 rows in total. What are the data types for each column. So we have that data site types for each column. So from our schema, our product name data type is string and new price data type is a float. Product name is a string and new price is a float. So let's check our progress to verify that we've completed the task correctly. So thank you very much. Now we've helped Meredith to learn more about the product sales and returns, as well as updated the product cost, and we have given them the information they need to complete their reports and better understand the look e-commerce pipeline. So these are examples of differences between standard tables and external tables, where they reside, reference, data storage, table statement, performance, and an example of the table. We would end our lab here, and I'll see you in the next video.